Georgie! Aren't you gonna say hello? Ah, come on, bucko. Don't you want a balloon?
I'm not supposed to take things from strangers. My dad said so.
Very wise of your dad, Georgie. Very wise indeed. I, Georgie, am Pennywise, the dancing clown. You're Georgie. So now we know each other.
I guess so. I gotta go.
Go? Without this?
My boat!
Exactly. Go on, kiddo. Take it.
I would, but the trash is in the way.
Ah!
Hi, I'm Santos,
And I'm Fabian.
and I'll be discussing the science portion of our project. The first point I'll be discussing is the effects of trash on our drainage. On average, 4.6 pounds of trash are thrown away daily per person. About 4% of this trash is thrown onto the streets. We get about 26 inches of rain per year in Harlingen. The rain picks up trash and clogs drains in neighborhoods. This, unfortunately, causes the neighborhoods to flood. This year alone, we've had the most amount of rain that we've had in the past 4 years at 39.07 inches of rain in total. This past June, we actually had several days of rain, which led to severe flooding in several neighborhoods. It is safe to say that if we had sewers that were not clogged, it would have been safer for people commuting to work or school. And now to discuss technology.
Thank you. There are several key components our design will have. Solar panels will be the key component into providing power to our design, giving power to the motors and sensors. The motors will control the mesh screens, arms, and walls that will come up to contain the trash that we will be clearing out. We will also be incorporating several sensors, such as proximity to detect when a person gets too close while the device is moving, force sensors to detect when too much force is being applied, and also humidity sensors, which will let the device know that rain has started and it is time to clear the entrances to the sewer drains.
Hi, my name is Rebecca, and today we're going to be discussing engineering and how it works in our idea. So, in order to prevent excess debris from clogging the drainage systems, we plan to use several mesh-like components for our idea. This catches trash early on while allowing water to continuously seep through. Though the first mesh-like component would be the layer holding the trash in place, the real work begins with the 2 mesh arms and 1 flap used to pick up the trash. This component would be activated through the humidity sensors whenever it is about to rain. However, not when there is excess moisture in the air. Once this is activated, we must then consider proper torque calculations to rotate the arms. Now that the trash is picked up, the real work is ready to begin.
Hi, I'm Salma.
And I'm George. And how we're applying art to our project is aesthetics.
For our first point, we decided to work with sound. We didn't want a machine that would disrupt people driving past or people who lived nearby. So for our second point, we decided to keep it compact and hidden. We didn't want a product that would obstruct drivers or keep people from walking on the sidewalks in the neighborhoods.
All right, for our third point, our product had to be eco-friendly. We can't have something causing more trash or causing pollution in the environment. Continue with our fourth point. It cannot affect green space. We cannot be taking extra area or land surrounding the sewers. It has to stay within the dimensions. And finally, to continue on to our next point.
Hi, I'm Christian,
I'm Cassandra.
and we're going to be talking about how we're going to implement mathematics in our device. So first of all, it's going to be used to calculate the dimensions of everything on the product, from the size of the drain to different components of the product itself. It is also going to be used to calculate what type of solar panel we will need and the battery life that will be needed to sustain the product.
Mathematics will be used to calculate the amount of voltage and current needed to power the device. It will also be used to determine what solar panels we will need to use in order to provide enough power. Essentially, we will use math for every aspect, from the most efficient gear type to the speed and which type the flaps will rotate.